Hi everyone, this is Elixir's most published author, Bruce Tate. In this video, we're going to talk about OTP, the soul of Elixir. This video is an introduction to core concepts. If you want to dive deeper, I invite you to come to Groxio. There you will find video courses and professional training opportunities to get that job or secure the promotion that you've been looking for. Let's go! Hey everybody, it's Bruce and the dog on the floor, and today we're going to continue to talk about OTP. Specifically, the idea that OTP is a library for processes with a common API for message passing and managing life cycles. And today we're going to focus on that common API. We're going to build a common API that does a shedding history. So it's really pretty simple. Whenever we get a new item to put on our history, we'll add it to the history, but we'll only keep a certain number. So that's a pretty straightforward business model, but I think it'll be pretty informative to show you how OTP is going to work under the hood, and it's going to give us some guidelines for how we structure our code. Let's get started. Before we get too far, let's play around in IEX and talk about what the overall API is going to look like. What I want to do is think about the initial input, and then think about the initial value for the GenServer, and then think about a series of transformations on the values that live inside the GenServer, and then maybe what those values are going to look like when we show them to the user. Okay, so our input, let's say since we're collecting history, let's say we're building some type of a command line interface, and so we're going to have a bunch of strings. And so maybe I have a bunch of strings joined by commas. So I'm going to say the input is equal to hello world. And I want to process that. And maybe it's as easy as string.split. And I have the input. And then I have, I'm going to split on comma. That's going to be okay. But I also want it to respond well for an empty list, but there's an option that does that. And it's called trim of true. Yeah, so this is basically what I want. And so if I build a function that works kind of like GenServers init callback, this is what it would look like. And I'm going to do it not in a module itself, but I'm just going to do it in IEX, so I'll capture it in an anonymous function. So we're going to think in terms of CRC, and those are construct and reduce and convert. This is going to work like the initial init callback. And this one is going to basically do a single reduction, or it's going to change the value of the GenServer based on the previous value. We're going to build the next value. And then whenever the user asks for the information that's in the GenServer, we're going to convert it some way. So we're going to run it into a function. But if I think about things in that way, then my backend is going to plug into my GenServer well. So let's say that I have this input, and I want to carve it up. Well, I'm really doing this right here, right? So I'm going to say the construct is equal to fn input. Okay, all that is an anonymous function, and it has one argument like that. And now I can start to build my pipeline. So I can say input, and I could pass that to my construct. And this dot is just a little bit of syntactic sugar in Elixir that allows me to work with anonymous functions. But the nice thing is that this flow is also going to work with an empty list as well. So that's cool. And the next thing I need to be able to do is to reduce. And my reducer is going to look like this. So the input is really a list. And it's going to have an item the new item for the history, but let's call the list history. and the item. And then all we're going to do here is say, I want to add the item to the history. And then I want to basically take that thing and I want to enum.take. I want to shed some of the items, right? So I don't want this to grow forever. Let's say I just want to grow to 5 or whatever my history limit is. So I'm going to call that much. Then I'm going to say end. Okay, so now I can start to continue my pipe here. So I have the construct, and then I can reduce, and I can say hello or Elixir. So now I have Elixir hello world, and then I can add to that, I could say, oh, I don't know, Bruce. And then we ought to start to see sheds around now. There's a last one, and now we should be shedding. Quotes shed. Okay. Yeah, and so now we've dropped hello world off. So this is what we want this thing to do. But sometimes we're going to send this whole list back to the client, and we don't want the client to think about how to process this. So we want to do the processing for the client with something called a converter, and that's basically preparing this thing for computation, right? So all we're going to do is take the items in the list. So we're going to say show is taking the history. It's taking the history in the list, and all we're going to do is do a enum.join. And let's say we're going to take the history and we'll join it on new line. Okay, so that gave me everything that I needed. So I ought to be able to take that and I ought to be able to pipe that to show. Okay, I get this command as expected. I can make that prettier by piping that to io.puts. Okay, so now I get the last, Bruce, Elixir, hello, and world, and that's what we're looking for. So now we have a pretty good idea for what our core layer is going to look like, and we're going to implement that next. So let's say mix new bike shed. I'm going to add the sub flag, and this is going to add the supervisor, and that's going to help us manage our life cycles. So that supervisor is adding this application right here, and everything else is like a typical mix project. So we're going to start working with that. I'm going to bike shed, and I'm going to say code, and then we're going to start editing our code. Okay, and so I have the lib, and here's the bike shed. This is where we're going to implement our GenServer. It's going to be use GenServer. But for right now, let's skip this work and skip right to the core. Here, I'm going to label this new file the core, though in a production setup, I would probably call this something like history. But what we're really trying to communicate here is that this is the functional core, and it has nothing to do with process machinery. So conceptually, I'm going to call this the core for this exercise. Okay, and so I'm going to say def module, and I'm going to say bike shed.core. And I'm going to have the def new, that's my constructor. I'm going to have the def add, and that is my reducer. And I'm going to have def show, and that's my converter. This is going to take an input, and it's going to return a bike shed. This is going, or whatever the core is, let's call it a history. And this is going to take a history and return a history. And this is going to take a history and it's going to return a string. Okay, so let's go ahead and implement these pieces. And so this was, we wanted to do a string dot split the input on a comma with trim true, and this was nothing more than, let's say, max length, and let's say that that's going to be, I don't know, just so it's easy to test, let's make it 3 for now. So let's say we want to do a history and the item. We want to add the item to the history and then pipe that much into enum.take and then max length. And then here we want to just, oh, I don't know, let's say inspect, or let's say history, and join that on new line. And one of our layers is going to print this out, but it probably doesn't happen here because this is the core, and in the core we don't have side effects whenever we can avoid it, right? So that work is going to move into the GenServer. Now all we need to do is implement this GenServer. Remember, all a GenServer is something that's going to, it's a plugin. It's a plugin that is going to manage process machinery with message passing, allowing us to set a state, allowing us to change the state, and handle message passing that's both synchronous messages and asynchronous messages to the client. So let's go ahead and implement that much. So one of the callbacks is a init. Remember, a init is going to take an initial input and it's going to return in an OK tuple the initial value of the server. And so we know how to build that value for the server because the value for the server is going to be taken out of our constructor. So we need to alias this core, and then this is going to be core.new. And now all I'm going to have to do is use very thin slices of the pieces from my individual history. Okay. We need 2 callbacks. One of them is just going to add something to the GenServer state. And so that can be asynchronous or a one-way message, and we're going to do that with a cast. And there's a great way to remember calls and casts. So a call, it's like a phone call, and phone calls are 2-way. That's call and response, right? And then there's a cast. That's like a podcast or a webcast. And those are 1-way. These are asynchronous. So synchronous 2 ways, asynchronous 1-way, right? And so the handle calls and handle casts are going to be the same way. Handle call and handle cast. And so I'm going to have a couple of functions that do these things. And the last argument of each one is going to be the history. And this is going to return a tuple. And the last item of the tuple is going to be history. And the first argument of each one is going to be the message that we're going to process. And since this is a two-way, we have a reason sometimes to track who this message came from, so we can access that here. We don't actually need it now because the infrastructure is going to manage sending the response back for us. And remember, this is phone call, two ways. This is synchronous. This is going to have a reply. And the reply is going to come next. And our reply is actually something that goes back to the client. One of the things that we could do is send the whole history back to the client. And if we do, we probably want to pipe that through our show, right? Our converter. But in our case, I think that the message that we want to process, this is going to be just get the history. How about show? And so the reply that we're going to send back is going to be core.show, and then the history. And then at this point, we probably don't want to change this history. Okay, that works fine. And then one last thing that we need to do, we need to be able to add something to our history, right? Now, if you look at this API, it doesn't look like we have enough arguments because we have a message and we have the history, but there's also an item that we have to sneak in there. So what we're going to do is we're going to make the message that we send a little bit more rich with a tuple, and then we're going to pass the argument to the message in with a tuple. This one doesn't need a tuple because there's no argument. So I'm going to manage the message, which is add. And then this is going to be the item. And then now I have to think about whether this is one way or two way. This is a cast, which is like a podcast or webcast. It's one way, so there's no reply. And the history, again, is going to be built by my core. So I'm going to say core.add, and that's going to take two items, the history and the item, right? So now I can go to the bike shed again, the history and the item, okay? And so if I want to, I can interact with this GenServer exactly like it is. And I don't need to do anything else. So let's go ahead and do that when we come back next. Okay, notice that there's a dot there, so I probably need to make sure that this is saved. Now I'm going to cut over to the terminal. Here we are, and now I'm going to run the project by typing IEX, and S is nothing more than start with uppercase S. I'm going to start mix, and now we ought to be able to interact with this thing. So let's go ahead and start it. So remember, when we build the GenServer itself, we start with the callbacks. And so far, everything that we built is made to be called by the GenServer itself. So this is called inversion of control. The control is actually held by the GenServer. We're going to tell it to start our application, our generic server, and then we're going to make it specific by adding our plugin, and our plugin is start link. So our plugin is the module that implements the GenServer, which is bike shed. Okay, and then I'm going to provide the initial argument for it. And all that is I could say hello world to start with some history, or I could start with the history being blank. So if I want to, I can go ahead and capture the process ID. And work with it this way. Okay, so what I've got is the process ID, but you don't have to take my word for it, or you don't have to remember all of this. All you need to do is say H GenServer, And this will show you how to interact with this, right? And so this is a stack implementation. Here's the stack. And this tells you how to interact with it right here. And we're actually right here, but instead of providing the stack, we provided the bike shed. And there's the initial argument. We provided our initial argument as well. So we have a running process. So I could say process.is or .alive, and then I can provide that PID. Or I can look it up to see if it's alive by saying GenServer.tab. And then you see this where is function. That's a directory that knows where the GenServer processes are. But I have a process ID. I don't really have a name, so we can't do that yet. So this is more effective, or this works to look processes up that are based on registered names. And so far ours is, we haven't registered a name yet. But we can interact with this thing by using messages. So let's say I want to GenServer.call or .cast. How about, cast. So cast is a two-way. No, I want to do a call. Sorry to jerk you around here. And this is a two-way call because I'm expecting a response back. What I want to get is the history. So I want to send the PID, and now I have to tell it what the message is, which is show. Now I have to get the whole history back, which is this. And so notice we're getting the response back, the exact response back that we expect. We have all of the history and we join it together with a new line, but since there's no history, we're not seeing anything here. But we can add to the history by interacting this with our calls and casts. This time it's going to be a cast. Why? Because it's one way. And this time the PID is going to be the same, but we also need to specify an item. And this is going to be an add. But we need to send all of this at once as a message, so we're going to wrap that in a tuple. Okay. Undefined function item. So, we need to give it an item. Hello, GenServer. Okay, so now we can look at our history again. And we probably ought to build a clean API that makes it a little bit less awkward to deal with our GenServer, and we're going to do that next. So this work that we're going to be doing is going to be strictly for convenience. And one of the things that we want to do is give this bike shed a name, and we can do that within a start link that we provide. Okay, so right here, these are callbacks. Why? Because the behavior in the GenServer defines them. And this is the contract that we must follow if we want to plug in to the generic server. So our plugin, what does it do? It makes the GenServer specific. In this case, we're building a shedding history. And so I also can have a convenient API that makes it easy to work with the client. Who's the client? The client is the calling process, not the process where the GenServer lives. So all of these functions are going to execute in the process of the GenServer itself. And all of these callbacks that I haven't written yet are going to execute on the client process. So, and we'll let the process machinery worry about getting across the wire. So what do we need to be able to do? Well, these three things. And so what are the corresponding GenServer calls? All of them are GenServer. So one of them is going to be, let's do all at once, right? So there's a GenServer dot, and the first one is going to be a start link, and then that's going to take arguments. And the other one, the next one is going to be a call. Why? Because we're handling the call here. And then the last one is going to be a cast. Right? Okay. So here's the first trick to making this a little bit easier to use. So we're going to actually build our own start link function, and we're going to call GenServers. But one of the things that we're going to do is give it an option of a name of shed. And now, rather than using the process IDs, I can use this shed name to interact with it, right? So I can say this is a shed, or I can say this is a history ID, and I can default that to shed. And I think I'm going to do that one instead. And these are also going to be functions. Let's implement the call. So def. And what does this do? So the call does a show. And then what arguments does it need? Well, it doesn't need anything other than this history ID, right? So I'm going to say history ID or shed. And then I'm going to implement that in here. And the show that we're going to do is just a simple message called show. And notice that I don't have to do any kind of receive, even though this is going to get sent back to my mailbox, right? So now I can implement that last callback, and that is def add. So this is going to allow me to add to the history. And how is that going to look? Well, it's going to, we're going to need to send it to a process ID. And we said that maybe it would be best to default this to shed. So let's do that. And now I can specify the last argument. And remember, this is add and an item, right? But this has to be a tuple, right? And this is going to go, but we don't need the end user to remember that whole message. All they need to do is provide the item, right? And then when I make the call, I can handle it here. Okay. So I want you to see the symmetry of this code. All of my APIs, the only thing that they know about process machinery is that we have to have someone else start them. And then we have to basically interact with a process, which I'm going to refer to by the ID, which luckily I can default, right? So the first argument for all of these things is the process ID. For all the messages that I want to send is the process ID. Then I have any arguments. And then all I'm doing is using the GenServer API. Oh, and this is wrong too, isn't it? And so I made a mess of that. So this is going to take an input, and I'm going to provide the module that has our implementation, and that's this one. And then I also have to provide the input for the starting element. So I think that I'm good to go there, right? So that's our full client API. But let's take a look again at the symmetry. So all of these things interact with processes, right? They're clients that call something that's already built. And the only thing that we should see that's related to a bike shed are the arguments that I pass to it. But what do we do within these show and this add? We use GenServer message passing, which is calls and cast. Call two-way, cast one-way. And what do we do on the front end? Well, we start the process up using a GenServer start link. That's all we have to do. And then once the process is running, That's when the inversion of control kicks in. We're not in control anymore. The GenServer is in control, and the GenServer is going to call back into our code when it needs to, when important things happen. Like a two-way message happens, I'm going to do a handle call. Like a one-way message happens, I'm going to do a handle cast. Like the GenServer starts up, I'm going to call on a init. So that's the symmetry that we're talking about. So now I can interact with this almost trivially, even though there's inter-process communication going on under the hood. So let's go back into IEX. And so I can recompile. And I actually need to exit here because, well, we've started GenServer with another set of arguments, and one of those arguments put the process ID in the process registry. So now we could say, if we wanted to work with the PID, we could. Or let's go ahead and kick this thing off. So let's say, okay, PID is equal to, and now I could say bike shed.startLink. I need to provide an input, and let's just pass that empty string. Now I have a PID that's 154. Remember that, because we can actually look it up also. Remember the name? The name was shed. We could pipe that into gen.whereis. It's the same process ID, and I can make sure that thing's alive. It's going to be alive by virtue of being in the list, but it's useful to do this exercise. It's alive and it's waiting for that first call or cast for us to send. So let's send it one, but we don't have to type these commands anymore. We can use the bike shed .add Now we can look at the history. Right? But you'll notice that this history has that new line in it, and that's annoying because we're always just going to print it out anyway. So one of the things that we can do is change our API to take advantage of that. Now this is a boundary layer, so it's okay to have side effects in here. So let's go ahead and make that change now. So I'm going to say the response is equal to, oh, not in there. I want to do it right here, right? So feed whatever comes back into io.puts. Okay, so let's save that. Now we can recompile because our process is still in the registry, and I could do bikeshed.show, and look, we're getting the items exactly as we added them, right? So the oldest thing is getting to the point where it's going to fall off the history, right? So I can add a third, and I could add a fourth, and I can add a fifth, and then I can do a show. And now our bike shed is shedding the history exactly like we want it to, and we could set that number any way that we want to. So what we have here is a way to manage processes where we could split the responsibilities between the process machinery, that's a GenServer, and the shedding history, and that's just core functions. And since we have packaged those into constructors, reducers, and converters, they are trivial to plug into our GenServer architecture. So we're going to keep on harping on that design. A lot of Elixir is built with the idea of transformations, and that means Elixir is reduced, and we are building our code that way. And that's an excellent thing. From Bruce and the dog on the floor, this is Groxio Learning.